Okay, so I just gave your homeworks back from, I think it was the By-Tree CS, is that right? And I have a few comments actually. I don't know, even if you got full credit on this one, your code might not be, it might be a little bit deficient. And I want to make a comment about this. Some of you are still not getting the point of polymorphic dispatch and using it to your advantage. Okay, and because it's possible to make these programs work and do all sorts of extra tests and do things at the tree level that you're supposed to be doing at the node level. And I went back and spent some extra time pointing out some of these deficiencies and showing you the way it should be done. And so I encourage you to look through I know these listings are getting kind of long, but scroll through your whole listing, because even if you got full credit, there might be some comments there that you need to be aware of. And let me say also that if you do unnecessary comparisons instead of taking advantage of the polymorphic dispatch, the decision that gets made implicitly in the polymorphic dispatch, if you do that on an exam, I'm going to take off some points. I didn't do it on the homeworks, but you need to know, because otherwise you're missing the idea, if you see what I mean. And there is there's one, I want to say a word also about efficiency, because there was one method here that where it's actually more efficient to use extra variables. And I want to point that, I want to show you how that works and why it's the case. So if you take, and the method that we're talking about is height. So this is the height for the non-empty. This is for the height operation for the binary search tree with the composite state pattern. All right. And what I want to show you is the non-empty node. Okay. Now, and so for the non-empty node, and so for the non-empty node, this is the most efficient way to do it. It's to have a little local variable. So this is non-empty node for height. I don't want to write down all the C++ code. I'm just going to do the statements inside the body. So here's the way to do it. I want to show you the efficient way to do it, and then a slightly non-efficient way to do it, because this technique, this pattern comes up frequently or occasionally when you program, and you need to be aware. We need to be good C++. What's the third goal of this course? C++. Okay, we need to be aware of how to do this. Okay, so here, what I said is int left height, and then said gets underscore left, because you're in the environment of a non-empty node, right? And we have an underscore left, underscore data, and underscore right. It gets underscore left dot height, and then int right height gets underscore right dot height, and then return 1 plus. And then we check to see if left height is greater than right height. So we say return 1 plus, and we do left greater than right height, greater than right height. So question mark. So if the left height is greater than the right height, then what do we return? Left height. Otherwise, what do we return? Right height. Good. So you know the logic anyway. All right. And then there's a, okay. Now, there's a way to economize our code here, right? Why have these extra variables, left height and right height? There's a way to make our code shorter, to make it more concise. And how could you make the code more concise without having left height and right height? You could just say what? And some people did this actually, which is good, but
1 plus underscore left dot height is greater than
right.
So, right dot height.
Yeah, exactly. So 1 plus. So don't have these. Have 1 plus left height, underscore left dot height paren, call that, is greater than underscore right height paren. And then if that's true, do what? Underscore left height paren, blah, 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 otherwise underscore right. Now, do you see that would be cheaper for you because you wouldn't have to write as many lines and you wouldn't have these extra variables. But why is that less efficient?
Because you calculate the height twice.
Yeah, these are function calls. And these function calls go all the way down the tree and blah, 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 blah. Now, does everybody see that? So in this case, it pays to have more code with these extra variables because you prevent the you eliminate a function, a whole extra function call. And by the way, that's extremely inefficient because each time you go down, you're doing it twice. Each time you go down, you see, because this is recursive, and each time on the recursive ones, what are you doing? That's way. Now, you have a feeling for how that's execution-wise. That's expensive in terms of how many calls get made ultimately in the computation. So this is a good way to do this. This is even though your code is longer. This is kind of like, I was going to say space-time trade-off, more space for our code, but the time is better. You know, I guess it would be maybe a space-time trade-off. Okay, now does everybody, you see how that works? So anyway, so here's one, and by the way, this happens frequently. If those of you who are in the programming paradigms course, you know when we did scheme, remember how when we did let and we learned how to do let and we saved the values that were computed and then yeah. So this comes up all the time occasionally. This comes up occasionally in programming. So you know, as we get more and more professional, we want to think about all the ramifications of how to do the algorithms differently, and this is just another technique in your toolkit. Now, okay, so were you going to ask a question?
Yeah, what's the difference between like outputting using OS and using just CERR?
Well, okay, so the difference is, what's the difference between OS and CERR? Mm-hmm. Yeah, okay, well, in the first place, OS is typically a formal parameter, and you can use, and the actual parameter typically could be either Cout or CERR. Are you with me on that? So that's one difference, is that typically OS is especially in our code in the DP4DS distribution, OS is a formal parameter, whereas CERR is, now, so one part of the answer is, what's the difference between CERR and Cout? Do you see what I'm saying? Here, so OS is typically a formal parameter that we pass, you know, and CERR and Cout are typically these are built-in standard streams in C++. These are standard output streams in C++. And the difference, so you were asking about the difference between CER and OS. Well, typically this could be, the actual parameter for this could be either CERR or Cout. In our DP4DS distribution, I don't think we ever pass CERR to OS. I think we never do. I think we always pass Cout to OS, to the output stream. Hold on. And then, are you with me? But now, what's the difference between CER and Cout? Cout sends a message to the output stream with just normally. CERR is a different output stream, and in our DP4DS distribution, in our NetBeans environment, it typically gets printed out in red because it's an error. And the reason there's two different output streams is because you might have, when you're writing in C++, you might want to have your error messages go to an error log. And so you would see, and so you could redirect CERR to an error log, and that way you can segregate your error messages from your standard output messages. So that's why C++ sets it up that way. Are you with me on that? And so what we do is we use CERR whenever we're going to crash the program. You know, whenever we implement a precondition, if the precondition is violated, we want to send out an error message, and we want it to be in red if it wants to be red, or somebody can redirect it to an error log file. Okay, so that's the intent there. Okay, so is that, are you with me on that? So we just bypass, you know, when we're going to abort the program because of a precondition violation, we just bypass any parameters, and because we're going to do throw -1, which is going to abort the program anyway. So we send the error message out to, we stream it to CERR, because that's the C++ standard error output stream. Yeah. This is, now, and here's another thing, you guys. I mean, I give credit to my co-author, Professor Gwynn at Rice. He is a research C++ programmer. And all of this stuff that we're doing, the way we set this stuff up, is all the way, we're very careful, he's very careful, to do it the way that C++ professional programmers do it. He is a professional research programmer, and he's in C++. And we're doing, so what we're doing is, it's a model. We want this to be a good model for how you would, you know, how it's done in the real world. And so all these standards with CERR and throw -1 and preconditions and all of this stuff, and returning, you know, returning constant references for, you know, all of this stuff, and setting up the correct way for the assignment operator, you know, overloading the assignment operator with deep copies, and all of that code, all of this stuff is the way it's done. And like I said, C++ is a really, really big language, and what we're showing here with this DP4DS distribution is the way that it's commonly done in the industry. So yeah, that's real. But that was a good question. All these questions. Third goal of the course: C++ programming. You know. Anyway. Okay. Any more questions?
Sure.
Yeah. Go ahead.
I just have a question about the insert root function. When you're in, because you only insert the root to an empty tree, right?
Yes.
So that root is pointing to an empty node.
Yeah, well, yes. So the point is insert root. Now, are you talking about doing insert root for the?
Not in the empty node case.
In the empty node, yeah, because if in the non-empty node case, it's a precondition violation, right?
So do you ever have to call delete this in the non-empty node case, or in the empty node case?
Yeah, in the empty. So the question is, do you ever have to call delete this in the empty node case? And the answer is, you can if you want, but it's not necessary. And I don't remember, did we do an example the other day where we did delete it, or now I don't remember.
Okay.
Because what happens is, if you delete, okay, the empty node has no attributes. That means when you new an empty node, then nothing comes from the heap. So it's not a memory leak to not delete it. Are you with me on that? So yeah, you can if you want, but we normally don't. Yeah, that was a good question. All right. Okay, so, and the other thing about that rem root is that I was really careful to get your homeworks back now, because rem root and I think root are the two methods that belong in the host of the bytree CSV project, and they have to be correct. Okay, so if you need those solutions, if you need those solutions to those, shoot me an email and I'll send you the solutions to that, so that you can make sure that your host of your bytree CSV project, which we're going to continue today. So in this figure, let's review then what we have. What we're doing now is we're doing the bytree CSV, and I think this is due tomorrow. Is that right? Yeah. So, okay, so here we have the host system, and the host system is just like the bi-tree CS, except for what extra method in the host system do we have that starts with an A? Accept. And what does accept always take as a parameter? A visitor. And that's how we get the plugins to work, so that we can compile a plugin and not have to recompile the host, and yet we can add functionality to the host. Are you with me? And then the host also provides an interface, the abstract visitor, but that's really for the purpose of the plugin developer, because the plugin developer does what? Inherits, his plugin inherits from that abstract visitor. And a plugin, because it inherits from an abstract one, it is free to add what? Extra things, attributes. So it can add as many attributes of whatever type it wants, and it will work with the host. And the host doesn't have to know anything about those attributes. So that's how we can set up our parameters. That's how we can pass information into and out of the plugin of arbitrary number, of arbitrary type, without the, and yet still have the host execute that plugin, not even knowing what those attributes of those actual plugins are. Are you with me? So how do those attributes get set by the plugin? They get set by the what at the beginning? Those extra attributes, how do they get set? What sets those extra little attributes to their initial values if they need to be set to their initial values? Starts with a C. Yes, the constructor of the plugin is that's where they get set. And again, unbeknownst to the host. All right? So then the code of the plugin can use those values that got set, that the user set to whatever the user wanted them to have, whatever the user wanted them to be. And then here in figure 8.42, we see that this is the key idea. The accept takes a visitor, and the root and the list version, the binary tree version of accept takes that visitor, and it just calls root arrow accept, and it passes the visitor along with its what? Star this, right? And then star this becomes owner for the empty case and the non-empty case. And what do the empty case and the non-empty case do? They take the visitor and use visitor dot. And that's how the host can execute the code that wasn't compiled in the host. Is that clever? Because accept is compiled once and for all. Are you with me? Accept is compiled once and for all in the host. But this is how the host is able to execute code that wasn't compiled with the host. And you can add the plugins. That's just the cat's meow. Here, let's take a look at figure 8.41.
Like it says accept visitor.
Yeah, and as far as the host is concerned, what is the type of that visitor? What does it say there?
An abstract visitor.
Abstract binary tree visitor.
Right.
So it's coded with the abstract one.
Right.
And it's compiled with the abstract one in the parameter list.
Right. But it just originally it only takes a visitor, but then when it goes to the nodes, it has a bi-tree and a visitor.
It is a binary tree. The host is a binary tree. The user's binary tree is...
But I mean, it's taking a binary tree and a visitor.
Well, yeah, but the host is a binary tree. So when you say, if you say my binary, if you have my tree, and you're doing it, my tree is a bi-tree CSV. It is a bi-tree CSV because it has an underscore root, and an underscore root is a pointer to a node, and a node can be either a non-empty node or an empty node, and it can be and have all that stuff. And then these are the 6 methods: root, left, right, insert root, set tree, and rim root. These are the 6 methods that you have access to with the host. And at the end of class last time, I think what we had done is we had looked at this isEmptyVis, all right, and looked at how, then this is just like the list version. We do for the empty case, we do underscore result gets true. For the non-empty case, we do underscore result gets false. And what does that do? That sets that parameter, that attribute, okay, called underscore root. And then on this, the next part of the figure 8.43, we have a method called result, and it returns underscore result. And then the global function for convenience is we have this global function called isEmpty that returns type Boolean and takes what as a parameter? A what? A binary tree. So this is global. But you give it the binary tree as a parameter, and then what does it do? What does this global function for convenience do? It sets up a little local what? Visitor, and calls and tree got passed as a parameter, and calls what? Tree dot what? Accept, and passes the what as a parameter? Accept takes what as a parameter? A visitor, yeah. And then because this returns a Boolean, then we call that little return function. So we return isEmptyVis.result. Right? And that's where we ended last time, I think. So these are the general translation rules. Remember, we had those 6 methods. The first 3 of them were for accessing the parts of a tree, of the host. And so here's the general translation rules. We use host.left in a bitree CSV visitor to correspond to underscore left in a bitree CS non-empty node. Because we don't have, see, our empty case and our non-empty case, they're not nodes. The only thing they have to work with is what? Their attributes and what? The parameters, right? And what's the parameter that they have, that they're always given? They're always given what parameter? What parameter are they always given? Here, back here. For the empty case and the non-empty case, what parameter are they always given? Yeah, let's take a look here in figure 8.43. So see, it's void, non-empty case, bitree CSV, and what is the parameter? Ampersand host, called by reference. Are you with me? So host is what we have. And then what other things do we have in our environment? Whatever attributes we have, which in this case is underscore result. So because we have host, so we don't have an underscore left and an underscore data and an underscore, but what do we have? We have host. And so what can we use for host? So what's the general translation rule? Instead, we don't have an underscore left, but for underscore left, we can say what? Host.left. And for underscore data, we can say what? Host.root. And for underscore right, we can say what? Host.right. See how that works? Okay, so let's do preorder. Here's bitree CSV preorder viz. So this is so the bitree CS version is void, so we don't have to have that underscore return thing, right? Because it's void. So therefore, the visitor does not provide a result method. The bitree CS version has output parameter OS. Oh, this is getting back to that OS being passed as a parameter. So the visitor version has a reference variable attribute underscore OS. So here's the code for preorder. And of course, you're going to do in order and post order, right? So check this out. What was a parameter becomes a what? What was a parameter in CS becomes a what? An attribute in what? CSV. So you see there's that private attribute, ostream ampersand underscore OS. Are you with me? Okay. And then, and what did we say? Where does that get set? In the what? We just said that a few minutes ago. In the what? In the constructor. So there's a constructor. When we set up a constructor, we give it, the constructor does underscore, well, that's a initializer list. So it's like underscore OS gets OS, which has got passed as a parameter in the constructor. Are you with me? And then we do the empty case and the non-empty case. Well, in the empty case, there's nothing to print out, right? But in the non-empty case, what do we do? What is preorder? What's the definition of preorder? Visit the what, then do a what of the what and a what of the what. Visit the root, do a what of the left child? A preorder of the left child and preorder of the right child. So here it is. So visit the root, underscore OS stream host dot root. Okay, because that's what corresponds to underscore data. Are you with me? Okay, and then some spaces. And then, now, this is a shortcut. We're going to reuse our same visitor and not instantiate a new one because this is more efficient, okay? Are you with me here? So what we're going to do is we're going to say, because what is always this? This is always a what to the what? Pointer to the current object. So what are we in? A what kind of object? No, wait. We are in a what? No, we're not in a non-empty node.
A non-empty visitor.
Well, no, there's not even a difference between an empty and a non-empty. We're just in a what? In a visitor. So, yeah, we are in a visitor, right? So what is this a pointer to? It's a pointer to a what? A visitor, which means star this is a what? Visitor, and that's what gets passed to a what? To accept. Accept takes a visitor. Yeah.
This is like probably not a very important comment, but just how we were talking last time, if you're not using the parameter in the function, should you just not name it? So like for the empty case, could we have deleted the word?
Oh, that's a good question. Except, yeah, I think you could. Yeah,
Okay.
Good point. Because we talked about that, not using it, and therefore it doesn't have to be named. And so for the empty case, you can. In fact, I wonder if that would be a good little test to try. See if that generates a warning message. Yeah. Yeah, I wasn't too consistent there, and here maybe I should have left off that name host. Yeah. And then so we do host.left.accept star this and host.right.accept star this, right? Yeah.
So like the alternate method would be like to make a new preorder viz object.
Yes. Actually, let me see if there is a global function for convenience. There is actually a. Let's take a look. Let's see how you would do that. Because one way to do it would be to use the global function for convenience. But the global function for convenience does the visitor and then calls it. So what is the global function for convenience? What's the name of it? It's preorder. It's preorder, but it's global. And so what does it take as a parameter? Output stream, and then a what? And then a tree. And so what does it do? Oh, and now look, it's setting up a visitor, and what's it passing as the parameter to the constructor?
No.
OS. So you see, that's where the parameters that used to be, they get set with the constructor. Okay, so it's by t CSV preorder viz OS, and then tree.accept preorder viz. So now think about it. We have a preorder global function. So what you could have done, let's come back to here. We could have done what? OS stream host.root, and then what could we have done? We could have done what? How would we instead of doing host.left.accept star this, what would we say? Oh, this is good. We would say what?
By TCSV.
No. We'll use this global function. Preorder, yeah, we would say preorder. We would say preorder what? Now what does preorder take? OS. So we would pass along OS, and then what else? A tree, right? So what tree would we want to give it? We would give it host.left. Like this. Are you with me? So this would be another way to do it. And then you would do preorder. And this would be OS, and this would be host.right.
And is that the same? It knows that this is the same OS that was originally put in?
It gets passed along, yeah. It's getting passed, and so yes.
Do you have to use underscore OS?
No, because the OS, oh wait, you're right. Sorry, you are right. This would be underscore OS. Because we are calling this from within here.
Right.
Yes. Good call. Now, but do you see that this is less efficient? You see that this is less efficient. Because what this is doing is this is setting up a whole new local visitor each time the call recursively. So it's way inefficient, but it's doable that way. Yeah, these are all really, I think we're getting, are we starting to get the hang of this? Yeah, question?
So the last 2 lines, what does this do exactly? It just,
It does okay, this whole thing is pre-order. This whole thing is printing out the tree in pre-order.
right. I'm just saying the last 2 lines that we just like.
Oh, these two? What I'm saying is
But like, that one, like originally, what is this exactly like saying when it says?
host.left.accept star this?
Yeah.
Yeah. It's doing this, well, okay. You understand, this is a pointer to the current object, and this current object is a visitor. So star this is a visitor. So what it's doing is it's calling this, it's calling this visitor, it's calling this visitor.
Within host.
Well, it's calling accept with this visitor, because this visitor already exists.
Okay. Oh, okay, so it's just calling that.
So it's
Left child case.
yes,
Okay.
yes.
And then, so why is that less efficient?
Because every time you do pre-order underscore OS host.left, what it's doing is it's going to here, and it's setting up its own local visitor.
And then in the previous case, it uses the one.
It uses the one that we already have.
Okay.
Now that was a really good question. If we can get that, yeah. In fact,
This one allocates more memory.
it does. A whole visitors all on the runtime stack. Visitors. Yeah. Yeah, that's really good. In fact, we're going to look at height. We're going to see the same thing with height. Or no, sorry, not height. We're going to do the same thing with num nodes. So check this out. Here's num nodes. So look at how num nodes works. Now, notice that num nodes is going to use the same technique of accept star this, right? So watch how num nodes works. So first of all, num nodes returns what? What type does num nodes return? What type does it return? An integer, because it's however many nodes, like 5 nodes. If 5 is an integer, right? So int. So that means that we're going to have this underscore result, right? As an attribute, and we're going to have a little, here, let's go on the next slide. And here, we're going to have this result thing, return underscore result. Okay? So it needs this underscore result. Okay, so now, check this out. What we're going to do is, by design, we are going to use this efficiency technique of reusing the same visitor. Okay? And because there's a different way to do it, but that would be take more computing resources. Okay, so look, what does the constructor do? Whenever we call the constructor has no parameters, but what does that constructor do for the num nodes viz?
Makes result equal 0.
It sets it to 0. So now we know that the very first time that visitor is set up, underscore result is initialized to what? Zip. To 0. Are you with me? Is everybody clear? It's set to 0. Now, in the empty case, what do we do? So that's this construction. Now, in the empty case, what do we do? Nothing. So underscore result doesn't what? Doesn't change. If we're in the empty node, we don't add anything to result. But on the other hand, what happens is, in the non-empty case, what do we do? We do host.left.accept what? Star this. So we're not setting up a new visitor. Instead, we are reusing the same visitor that has been where underscore result has been what? Initialized to 0. So there's only one instance of the visitor, and therefore there's only one instance of what? Underscore result. So we do that, and we do, and what will host.left.accept star this do? It will add however many nodes there are on the left, and then the host.right.accept star this will add however many nodes there are in the right tree, and then what will we do? Underscore result plus plus. And this is based, and you guys, this is based on the fact that we're doing star this, right? Because underscore result is initialized to 0, and so here is the result is the same, int result return underscore result, and here's how you would do the global function for convenience. So check this out. If you wanted to know how many nodes are in my tree, you would pass what? You pass tree as a parameter, and what would this global function do for convenience? It would do what? Set up a little local visitor, tree.accept the visitor, and then that tree.accept sets the underscore result, and then this global function for convenience returns numnodes viz.result. Yeah, now let's see how we could do it the long way, the inefficient way. You have a question?
What happens if you call this when you're in the global function?
There is no this. There is no this because it's global.
Okay.
Oh, that's a good question. There is no this in a global function. By the way, global yeah. So compiler wouldn't compile. There is no this. Yeah. Mm-hmm.
Can you repeat like when it knows, or like how it is called, the like empty case versus the non-empty case? Like when is that called?
Yes, that's a very good question. And the answer is, let's go back to this. When is the empty case and the non-empty case called? Now watch this. If we go back to figure 8.42, what happens is that code for calling it got compiled once and for all in the host.
Right.
So notice that the host does root arrow accept. That's why in the CS version, the composite state version, we did the tree version, and then the empty node version, and then the non-empty node version. But in this case, what happens? The host does the tree version because it's always the same, because always what gets passed is star this and the visitor. So we only have to worry about doing the empty case and the non-empty case, but that got called, the host code got generated as what's doing those calls to the empty and the non-empty.
Okay.
Yeah, that was a good question.
So it's the empty node or non-empty node calls the empty case or the non.
Yes, notice that it's the empty CSV node calls visitor.empty case owner. See, because the empty case and non-empty case are what's provided by, what's provided by the abstract visitor. Yeah. See, yeah, I tell you, is this getting better? Are we getting more? I think as we do this more and more, it becomes more and more clear. Even for me. So the numnodes visitor, global function for convenience does this. Now let's go back and see how we could do this let's see how we could do this differently, less efficiently. What could we do? If we didn't reuse star this, what would we do? The constructor, so here's less efficient num nodes. So first of all, what we could do is, for the constructor, we wouldn't no initialization in the constructor. Are you with me? So here, no initialization in constructor. No initialization in the constructor. And then what would we do? In the empty case, what would we do? Yeah, only we wouldn't return 0. We would do what?
Result gets
Yes, in the empty case, we would do underscore result gets 0. Do you see what we're saying there? All right. And then what will we do in the non-empty case? And here, if we want to, we could use the global function for convenience. I mean, we could set up our own, local visitors here, but why not use the global function for convenience? So what would we do? Now, what would we do for the non-empty case? It's a one-liner. We could do it with a one-liner using the global function. We'd do underscore result gets what?
No.
Yeah, well, why not just one? Yeah, 1 plus. We could do that at the beginning or the end, but anyway, I'm thinking. Because, see, we are in the non-empty node, right? So what do we want to set underscore result to? We want to set it to what?
1 plus left.
1 plus, but now we got to go to the global. We've got to go, how do we use the global function for convenience?
Num nodes with the.
Num nodes, 1 plus num nodes what? Now what do we have to give num nodes?
Post dot left. Post dot left.
Yeah.
Post dot left.
Host, I think it's host dot left is the tree, right? So this would be host dot left, and that's a function that returns a tree, right? And then what? Plus num nodes host dot right. No, and this, but then the code for underscore result stays the same. I mean, the code for for result stays the same. But what this is doing is, you see now, but there's lots of underscore results because there's new visitors for everyone, and they all have their versions of of underscore results, and those results are getting set, and the visitors are getting allocated and going away, and all those results are getting all set and added to, and then they're getting returned and blah, blah, blah. So this is way inefficient, but it's doable. Now, this is really, are we good? I think this, okay.
Because if you do it with just one visitor, there's only one.
There's only one attribute, yeah, and we are using it. We know that between calls we are using it, yeah. So is everybody good with this? Are we good? Okay, and now let's take, I think the next one's going to be equals. So here's equals, and I just want to take a look at the environment for equals. Okay, now equals, now check out what we have for equals. We have, for equals, first of all, does equals return a value, yes or no? Yeah, it does. What is it? Type bool, right? So we have an underscore result bool. But remember, we have RHS, because we want to see if two trees are equal. Are you with me? So you get out the, and most of it, with the guidance we gave you, most everybody got the equals for the by tree CS. Okay, so go to your code for that and just translate it. Okay, so look. So RHS now is an attribute. And so what does the constructor do? It does underscore RHS gets RHS initialized. And now the empty case is an exercise for the student, and the non-empty case is an exercise for the student.
There's an equals helper too there.
There is going to be an equals helper also, but look. That now what I want to do, oh, and then underscore, and then the result is the usual thing, right? The precondition, this visitor has been accepted by host tree. Post true is returned if the host tree is equal to RHS, otherwise false is returned. Two trees are equal if blah, 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 blah. Oh, and by the way, also, the global function for convenience is going to be overloading the equals operator. So this will be a new little twist for you to I don't think have you ever coded an overloading operator before yet? Anyway, here's one. Go back and see how that's done see how we've done that in the past. But here in figure 8.47 is a contrast of the environments. Now check this out, you guys. Here again, if we can just get this idea of when we are programming with an object, they are these little local self-contained things, and their environment consists of what? Attributes and parameters. So in the old case, in by tree CS, the empty node for the equals, didn't have any attributes, and it just had a what? An RHS, which was a binary tree. Are you with me? And the non-empty node had a what? An underscore left, an underscore data, and an underscore right, which were its what? Attributes, and an RHS, which was its parameter. Are you with me? Now we have only one environment that corresponds to the both. Are you with me? So what we have is host, which is the what? Where does that come from? That is the what? This host, in our environment of a bi-tree CSV, this host is a what? Where did that come from? The environment consists of, where does the environment come from? Parameters and attributes. Which is that host? Is that host a parameter or an attribute? No, what is host? Come on. It's parameter. Right? Host is a parameter. And underscore RHS, we just looked at the code. Underscore RHS is the what? Is the attribute. And then underscore, and then we also have underscore result that we have to deal with. Are you with me? Now, you guys, what do we have to do? Because in the original one, the environment of a non-empty node had underscore left, underscore data, underscore right. But what will they correspond to? Host dot what? Left and what? Host dot data and what? Host dot right. So when you make the translation, you do that. Now,
Do you do
go ahead.
host.data or host.
Oh, sorry. Did I say? I might have said data. I meant root.
Okay.
It's host.root. And now we're right in the middle. It's the cliffhanger. At the beginning of class tomorrow, we're going to take a look at the environments of the helper. It's, okay? But if you just keep them straight, you can check out the slides, but we'll go over that tomorrow. And it's not due till tomorrow anyway. All right, I think we're getting it. I think we're... Okay, good deal. See you tomorrow.